Less than a year after its launch, Japan's XRISM X-ray telescope is already making waves. In a recent study published in the journal Nature, astronomers presented the first results from this groundbreaking telescope, including an observation of a never-before-seen swirling plasma around a supermassive black hole in the galaxy, NGC 415162 million light-years away. They also studied the remains of a star explosion, a supernova remnant called N132d, which is located in the same galaxy. Here's what they found. First, let's talk about that black hole. Supermassive black holes are the ginormous centers of most galaxies, including our own Milky Way. But despite their immense size, they're surprisingly difficult to observe directly. That's because they don't emit any light or other electromagnetic radiation that we can detect. The only way we know they're there is by watching how stars and gas move around them, and that's exactly what XRISM has done. By studying the way plasma swirls around the black hole in NGC 4151, astronomers were able to map out its three-dimensional structure for the first time ever. They found that the plasma forms a sort of twisted torus shape, which is consistent with what we expect to see based on computer simulations of black hole accretion disks. This type of observation could help scientists better understand how black holes grow over time by consuming the material around them. But that's not all. The X-ray telescope also observed a supernova remnant, the debris left over from a star that exploded. Specifically, they studied an object called N132d, which is located in the same galaxy as the black hole. By analyzing the X-ray data, astronomers were able to create a detailed map of the supernova remnant and measure the speed of the expanding plasma. They found that it's moving at a mind-boggling 2.6 million miles per hour. That's equivalent to about 1.1 million kilometers per second. The researchers also measured the temperature of the plasma, which reached a scorching 18 billion degrees Fahrenheit. That's more than 10 times the temperature on the surface of the Sun. Overall, these observations are just the beginning for XRISM. As the telescope continues to collect data, it's expected to revolutionize our understanding of black holes and other high-energy phenomena in the universe. One of the most exciting things about XRISM is its unique X-ray mirror. Unlike other telescopes, XRISM uses a grazing incidence mirror, which means that the X-rays hit the mirror at an angle. This allows the telescope to focus X-rays to a much smaller area, which makes it more sensitive to faint signals from distant objects. So what does the future hold for XRISM? The mission's principal investigator, Professor Andrea Ferreira, says that the team is eager to continue exploring the mysteries of the universe with this incredible new tool. They're particularly excited to study fast-spinning neutron stars known as pulsars, as well as the black hole at the center of our own galaxy. With its unprecedented sensitivity and resolution, XRISM is sure to make many more exciting discoveries in the years to come.